Hello, grade 11s. We are back. We continue with your work. Today we're doing maths, nature of roots. And remember, guys, your grade 11 is the most important year. So we are covering work that you'll need next year when you are in grade 12. Right, let's just look at the overview of this chapter. The methods that we're going to be using, a reminder, it's factorizing, square rooting, completing the square quadratic formula, and it has got links as well, which is your inequalities, quadratic function, parabola, and so forth. Okay. Right. The terminology that I want you guys to be looking at today is, one, what the following terms or words mean in maths. Your conjecture, roots, rational number, irrational number, perfect square, imaginary number. Okay? So what I'm going to ask you to do, guys, now, is to, wherever you're sitting, you work out what these terms mean. Conjecture, your roots, rational numbers, and so forth. And I'm giving you 2 minutes to work on that. All right, mindsetters, you've worked around the meanings of these words. But what I'm just going to do for you for now is to show you a little bit on how you can be able to use these words in maths. All right? Now, remember, a conjecture, we are working out a certain formula or a conclusion that we are coming up with, all right? So, for instance, you've got 2, 4, 6, 8, and then you're looking at the pattern, you can generate a formula to work out the next terms and so forth, something like that. And then with your roots, if you have, for instance, this is your graph, that's -1 maybe, and then that's a 5. So we call these guys, the 5 and the -1 are the roots of this quadratic function. So this is x, and then that is y. And then we've done your conjecture, your roots, and your rational number. Remember in grade 9 that it's that number that you are able to write in a form of A over B. So in simple terms here, like 4 is a rational number because you can write 4 as 4 divided by 1. And maybe 3 over 7, it's also a rational number. Okay, so we'll be answering those along the line. And now what I want you All right, what I want you guys to do is 2, and then when we are checking, let's just check if we've done all of them, right? Your irrational number, your perfect square, and your imaginary number. So your irrational number, you are not able to write it in a form of a over b, right? So for instance, you've got a square root of 7. That can be one of the examples of your irrational number. And then a perfect square, giving examples here, 1, 4, 9, maybe 100, and so forth. And your imaginary number, as we'll be looking at it as we move on, it's like negative square root of 4, negative 20, and so forth. All right. So now let's get to the lesson. I want to give you an investigation, right? Use the quadratic formula to determine the roots of a quadratic equation given below and take special note of the expression under the square root sign and the type of number for the final answer. And you use the following words to describe the roots. You use your rational, irrational, real, imaginary, undefined, unequal, and equal. Okay, this one is duplicated. Okay, so you've got A, B, and D. So you need to check the expression under the square root sign, how is it, and the type of the final answer, and then you are using those words to describe. I'm giving you, again, 2 minutes to work on this. All right, well done, guys. I can see all of you are working very hard. Let's just quickly look at these problems again, right? So we take the first one. You've got your x squared minus 6x plus 9. How do we use a quadratic formula there? All right, now let's go. So your x is minus b plus or minus the square root of b squared minus 4ac all over 2a, right? So that's minus b, which is a 6, plus or minus the square root of b squared minus 6 squared minus 4. Your a is 1, and then your c is 9, all divided by 2, and then a is 1. All right, now let's simplify that, guys. You've got 6 plus or minus the square root of 36 minus 36, which is a 0. So you've got 6 plus or minus 0, which gives us a 3. Now let's take note, guys. We have only one as our solution, which is x equals to 3. Okay, the expression under the square root sign, okay, we notice that this is 0. Okay, and then the type of a number, the final answer is a rational number. Okay, and then you have to describe this in words. Okay, so what we discovered for this example is that this is real. Okay, and it's also a rational number, and then it will have equal roots. Okay, like now I've given you this B and then also D to also look at. We'll just quickly run through. So x here for B equals to minus B, that's minus minus 4, which is 4 plus or minus the square root of negative 4 times negative 4, that's 16, minus 4a is 1, and then c is 3, all over 2 by 1. Then we get here 4 plus or minus, that's 16 minus 12, so that's the square root of, that's 16 minus 12, so you've got a 4 there, all over 2, which gives us 4 plus or minus 2, that's a 6 over 2, or 4 minus 2, which is a 2 over 2, and that's a 1, and that is 3. So now, watch what's happening here, guys. You're getting x equals to 3 or x equals to 1. So you've got two roots for this particular quadratic equation. So number one, again, we go back here. It is also rational, and it's real. But then the roots are not equal, so it's unequal roots, okay? And then we also look at the last one, your x squared minus 4x plus 7 equals to 0, and we all know how to use a quadratic formula, so your x is minus b, so it's minus minus 4, which is a 4, plus or minus square root of minus 4 squared, minus 4a is 1, and then c is 7, all divided by 2 bracket 1, which gives us a 4 plus or minus the square root of 16 minus 28, all divided by 2, which gives us 4 plus or minus the square root of 16 minus 28, that's a negative 12, all over 2. Even if we don't continue, guys, watch, you've got a square root of a negative number. Even if you press your calculator, it's going to tell you math error. Now remember what we said earlier, that is an imaginary number. Okay, right. Now we proceed, guys. Now your investigation is to, you've got the expression under the square root, which is your b squared minus 4ac. Remember, when we're writing a quadratic formula, it's x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. This is called a discriminant, all right? And is given the Greek letter capital, which is delta, all right? Now, can you make a conjecture about the relationship between the discriminant and the roots of a quadratic equation? I'm going to give you 2 minutes to work on this, right? You work out what your discriminant is, and then you also give us the roots. 2 minutes. Right, guys. Now let's just check if you were right or right. You've got x squared minus 6x plus 9, right? The discriminant, as we were saying earlier, that it is b squared minus 4ac and is represented by this delta. So your b squared, it's minus 6 all squared minus 4. Your a is 1 and your c is 9. That's equals to 36 minus 36, and that's 0, right? So now we'll come back just now to this one and we talk about the roots. We come to b. Your b squared is minus 4 all squared minus 4a is 1, c is 3, which gives us 16 minus 12, and that's a 4. Now you'll notice something, right? So this is 0, it is real, okay? You're getting a 4 here, that's also real, all right? Now, remember, again, you will be checking this now. If it's a perfect square, that's also going to be rational, all right? And you can write it in a form of a over b, all right? And you've got rational. So it's real and irrational for these ones. I'm going to give you a quick break, and then we'll come back and we unpack the whole of this. Welcome back, guys. Now, in this chapter, we'll be looking at the key concepts. And we know that for a quadratic equation, it's always in the form of ax squared plus bx plus c. And the nature of roots can be determined by inspecting the discriminant as follows. If your discriminant is less than 0, then your roots are going to be imaginary or non-real. So now we're getting something like this. It's negative 4. At this level, we only concentrate on the fact that they are non-real. And like I said earlier, if you press your calculator, you get it's a math error or something like that. But when you grow older, you'll know that these are imaginary numbers, then you get 2i, right? And then if your discriminant is greater or equals to 0, the expression under the square root is non-negative, and therefore roots are real. So now if you get your square root of b squared minus 4ac to be maybe like 15, right? So you'll get the real roots there, right? That's number one. The square root, under the square root, it's not negative. For real roots, we have the following further possibilities. If your discriminant is 0, the roots are equal, all right? And we can say that there is only one root, right? So looking back at the example that we got, the x squared minus 6x plus 9, right? If you work out your discriminant, your b squared minus 4ac, you end up getting 0. That's the example that we worked on, all right? So now we're going to say those roots will be equal, and then there's only one root in actual fact. But then this is how we're going to write it. This is equals to 0. What do you get here? If you factorize the x squared minus 6x plus 9, you get x minus 3x minus 3. You get x equals to 3 or x equals to 3. So you see you're repeating the same thing. So there's one root there. Now, if your discriminant is greater than 0, the roots are unequal, and there are two further possibilities for that. Your discriminant is a square of a rational number. The roots are rational, right? So like the one that we got 4, right? So 4 is a perfect square, so you can write it in the form of a over b. And then if the discriminant is not a square of a rational number, the roots are irrational and can be expressed in a decimal or a set form. Okay, now looking at the pictures on how you can tell if you're given in a graph like the nature of roots and the parabola. Roots are non-real, right? The discriminant is less than 0, all right? So you see our graph here, we're not touching the x-axis. We're not touching the x-axis, so these are non-real roots. So you cannot tell what x value is. In actual fact, it is not there. Roots are equal, roots are real and equal, right? So you get a situation where this is maybe 2, all right? So in other words, this is a parabola in the form of ax squared plus bx plus c. So you get a situation like this, x minus 2 all squared equals to 0. It's real, and we also have equal roots, which is in this case 1x value. Without solving for x, determine the nature of roots, okay? We've spoken about how you can tell that these roots are real, irrational, rational, equal, and so forth. So I'm giving you again 3 minutes to work on these 4 problems, okay? X squared minus 2x plus 2, blah, 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 up to your D. 3 minutes, guys. Let's work. Well done, grade 11s. We now proceed to saying without solving for x, determine the nature of roots. Okay, now remember what we said. How do we tell about the nature of roots? We use the discriminant, and your discriminant is that under the square root, okay? So the b squared minus 4ac. Okay, let's go and do it. All right, so our discriminant here is b squared minus 4ac, and your b is minus 2 squared minus 4, and your a is 1, then your c is 2, okay? Now, that's 4 minus 8, we get negative 4. Now, watch what is happening. You get a square root of a negative number. What is going to be your conclusion here, guys? Square root of a negative number, this is imaginary. Okay, so your roots are imaginary, all right? So you've got non-real roots. So roots are non-real. Let's look at the next problem, because we cannot be even able to factorize and work it out and find the values of x. It's like those first examples of the parabola where it doesn't touch the x. Now let's look at the next one. Your discriminant for b, it's b squared, which is minus 6. That's the square root of b squared, that's 36, minus 4 into a is 1 and c is 9. You get the square root of 0, and then that is 0. Okay, so the roots here are real, right? Rational. And then remember, if you get a discriminant, it's equals to 0, right? And then you'll have equal roots as well, right? So they are real, rational, and equal. Now, we look and the next one. Without solving for x, determine the nature of roots, okay? So our discriminant here will be b squared. Okay, the square root of b squared minus 4 is, so you've got square root of b, it's negative 5, all squared, minus 4, what's your a? It's 2, bracket c is minus 7. Now let's simplify. You get a square root of 25 plus 8 times 7, that's 56, which gives us square root of 81, and then you get a 9, right? So you conclude by saying, okay, the discriminant now, watch, is greater than 0, okay? So you've got real roots, right? And then it is also a perfect square. You've got the rational, right? Rational roots, okay? But if your discriminant is equals to 0, then you get equal roots. So here the discriminant is 9, so you'll get 2 unequal roots, so and unequal. Okay, right? And then now we move on to the next problem. We're still answering the same question. We're not solving for x, but we want to tell the nature of these roots, okay? So your discriminant here will be b squared, square root of b squared, that's 25, minus 4, your a is 3, and then c is minus 3, okay? So you get a square root of 25 plus that negative times negative, that's a 9 times 4, you have 36, which gives us root 61, okay? Now watch, the discriminant is positive, you get real roots, okay? So this is real roots, okay? Now next, you're not getting a perfect square there, all right? So we said for the discriminant to be a perfect square, then you get rational roots. But this one is a square root of 61, so these are irrational. And then if your discriminant is 0, then you get equal roots. So it means that this one will have 2 unequal roots. Unequal roots. When you're working out this problem, if I'm asking you to solve for x, so you are easily able to tell that, okay, now it's not going to be less than 0, the discriminant, so you will be able to work out the x values, those 2 x-intercepts, if you're looking at it as a graph, but they will be irrational, all right? So you need to round off maybe to 2 decimal places or 1, and you'll be using a calculator. So this one, you're not going to be able to factorize it straight away. So it means that you can either you complete a square or you use a quadratic formula, okay? Now, consider the equations and match each one to the statement which best describes its roots, okay? I'm going to give you 2 minutes because we have looked at this now. You will be able to work it out. I'm going to give you 2 minutes to do number 1 and 2. Then from there, I'm going to help you. Then we go for a break again, guys. Okay, let's work 2 minutes. Well done, grade 11s. Let's look at number 1 and 2. We need to tell whether they're real or non-real and so forth. Okay, so we start with number 1. Okay, so your discriminant is equals to b squared. So that's minus, it's minus 7. Okay, that's minus b squared minus 4. A is 1, and then c is negative 18. So you've got your b squared, which is negative 7 squared, that's 49, plus, now guys, you've got calculators at home. I'll just do it a traditional way, times that. So you've got 862, that's 72, all right? So this is, we're getting 1, 1, 2, 1. So you've got the discriminant is 121. So it is positive. So we've got real roots, okay? Okay? And then it's a perfect square. You've got also rational roots. And then, but it is not 0, so the roots are not equal. So you have unequal roots. So which one are we choosing? There's real, so you've got real here and there. Rational, so it's rational, but unequal roots, so it means that we go with B. All right? And then we do number 2, it's 25x squared plus 20x plus 4. Let's just do it on the next page. So your discriminant here, it's b squared minus 4ac, so your b is 20 squared minus 4, your a is 25, and then your c is 4, all right? So now we have here, this is 400 minus 25 times 4, that's 100 times 4, that's 400. Then you've got 400 minus 400, that's 0. So you've got a discriminant is 0. Now let's tell what kind of roots are we having here. Number 1, discriminant is greater than 0, so you've got real roots, all right? 2, you have 0, so this is rational. And then you also have, the discriminant is equals to 0, then it means that you will have equal roots. Equal roots, so we go for A. Now, guys, I'm going to ask you to take a very quick break, and then you go and drink some water, and then have some tea, and then we come back after the break, and then we continue with our session. Welcome back, grade 11s. We continue with our problems. Consider the equation and match each one to the statement which best describe its roots, okay? We said we're going to tell the roots by working out the discriminant, which is b squared minus 4ac. So that's 7 squared minus 4a is 2, and then your c is 4, which is 49 minus, that's 16 times 2, that's 32. And then you get, is that 17, something like that. Okay, so the discriminant is 17. 1, it is positive, so you've got real roots, okay? All right, and now you've got under the square root. Remember, this is x equals to minus b plus minus square root of b squared minus 4ac. So that square root, you have root 17, so it is irrational. It's not a perfect square. And then, because it's not 0 again, it's unequal roots. Okay, unequal. Spelling, maths. Right, so you get C there. Okay, now the next problem, you've got 3x squared minus 5x plus 3. So your discriminant will be b squared, that's minus 5 times minus 5, that's 25, minus 4, a is 3, and then c is 3. We get 25 minus 36, and that's negative 11, right? So our discriminant is negative 11, so we get a negative square root, so it means that we have non-real or imaginary roots, so that is your D. And well done to all of you who've got all of this correct. Now, we proceed. Now you given x squared minus bx plus 36. You need to find the values of a, b, or c to match nature of roots given. All right. So for real roots, rational, and equal roots. Now remember, for real should be greater than 0. Rational, you must have the discriminant has to be a perfect square, and for equal roots, you must have a 0, right? So your discriminant has to be equals to 0. Okay. Now again, guys, I'm giving you these problems. We quickly work on them. Give you 2 minutes, and then I help you work out the outcomes. Then 2 minutes, guys, and then I continue and help you. Well done, guys. Let's now see those of us who are still struggling. Okay, let's go to the question. X squared minus bx plus 36 equals to 0. The unknown there is b. Right? We need to work out the value of b if the roots will be real, rational, and equal roots. Okay. So the key here, you've got your equal roots. Then your discriminant should be equal to 0. All right. So you've got your discriminant equals to 0. So your b squared minus 4ac is 0. So you have minus b all squared minus 4. Your a is 1. And then your c is 36 equals to 0. All right. So you get b squared minus 4 times 36. Okay. Now, because I don't have a calculator with me, I can see that this is a difference of 2 squares. So I can factorize this by saying we have a b times a b minus and a plus, right? Square root of 4 is 2 times of 6, of 36 is 6. So you get a 12, and then a 12 that side as well. So you've got b is 12, or b is negative 12. Now, guys, watch. If you take the value of b and substitute here, all right, so you get x squared minus 12x plus 36 equals to 0. You factorize, you get x minus 6 all squared is 0. Then your x is 6, or x is 6. Now you see you get equal roots, and they are real, and they are rational, because your b squared minus 4ac is a perfect square. All right. Now we move on to the next problem. Okay, ax squared plus 4x plus 2, you need real, rational, and equal roots. So it's still one and the same question, but in this case, we're working out what a is. Now remember, you'll have your b squared minus 4ac, right, equals to 0, all right? So you've got your b, it's 4 squared minus 4, a is a, and then c is 2 equals to 0, all right? And then this is 16 minus 8a is 0. Then you have, take the 8 across, then divide by 8 throughout, you get 2 is a. So in other words, if you substituted 2 here, you get 2x squared plus 4x plus 2, and then you can as well take out the 2 and factorize x squared plus 2x plus 1. Then you can see that this is, you can easily factorize x plus 1 all squared, and then you've got x is minus 1. Okay. Now, find the value of c to give this non-real. Now, what happens if we're working the non-real roots, okay? So your square root, you'll get a square root of a negative number. So in other words, your discriminant should be less than 0. Now, what's our discriminant? That's b squared minus 4ac should be less than 0, all right? Now, b is, you get 8 squared minus 4, a is 1, and then you have c, which is c, should be less than 0, right? So you've got 64 minus 4c is less than 0, all right? So you've got minus 4c is less than negative 64. Then you divide by negative 4 throughout, c should be greater than, now what is 64 divided by 4? It's 20, no, sorry, that's 1, and then you've got a 24, 6, 12, 18, 24, so you get a 16 there, right? So your c should be greater than 16, all right? So for this to be non-real, you must have this to be greater than 16 there. If you sub in a number like 17 or 25, then you'll get a square root of a negative number, okay? So if it was 16, you will be able to have only one real root there. All right, now again here, we're working out what the value of b is, but for non-real roots, okay? Again, non-real roots, the square root of a negative number, okay? So the discriminant should be less than 0. So your b squared minus 4ac is less than 0. So you've got minus b squared minus 4, your a is 3, and then your c is 3, that's less than 0. So you've got b squared minus 36 is less than 0. Now, watch. Guys, you don't say b squared is less than 36 and then b squared should be less than 6. This is a difference of 2 squares. You can factorize the b and the b, 6 and the 6, minus and plus. Now, going back to our inequalities now again, guys, you will have a negative 6 and then a 6. But it's below, remember with your inequalities, it's negative, it's below your x-axis. So you're reading off your solution below the x-axis, right? So your x should be between minus 6 and 6 for you to be able to have the roots that are non-real. All right? So guys, thank you so much for listening and working very hard during this lesson. Hope to see you next time and working hard. Thank you. Bye.